Hello everyone, this is what we're going to be doing today. Tile animations, finally. This was a bit of a tricky video to make, not because programming tile animations is hard, but it was a little tricky to find a good tile set that actually has some animations, because our Kenny one does not. But thankfully I found this really beautiful one right here called Slates by somebody named Ivan Voirol. Anyways, it says 32 by 32 pixels, but I actually scaled these up to 64 by 64 pixels, just like the other ones. And as I explained earlier, the reason for that is I don't want to make the whole video about screen scaling, but you can use whatever scaling system you want, or you can just use my assets. Either way is fine. That's not the important thing. But this does actually have some animations, like if we look at the waterfall here, that's going to be an animation. And this water wheel right here is another animation. And notice how this is actually two different tiles. So each one of these is going to be a separate animation. That'll be fun to program. But there is one little problem I have to address. In order to create all these beautiful shadows and things, I needed a third layer. But if you remember from earlier, our system for rendering the maps only supports 2 layers at the moment. Like this one is only 2 layers, and the other one is only 2 layers. So I'm going to have to refactor the map system to be able to support a variable number of layers. Thankfully, that's not really hard to do, but I do have the colliders in place for this, and I have the player entity right here. And one cool thing I discovered from doing this is you can actually copy and paste this player into this map, and it will display correctly. And the reason for that, I discovered, is that Tiled actually supports multiple tile sets in a single map, which is really nice because you can actually have a separate tile set just for your entities if you want to visualize them in the editor. But anyways, we're going to use it as it is, so I'm going to export this and then refactor our code. Okay, so I'm back here in my map object, which handles rendering the maps. You can see that the layers are just hard-coded in like this inside of this tiles table. I don't want that anymore because I'm going to loop through the map definition, get all the tile layers, and then place them in this table. So what I'm also going to need is a variable called tile layers count. Now you may be wondering, why don't I just do this to keep track of the number of layers? I could do that, but I might change the way my tile system works, so I think it's better to have a separate variable for this. Now if we actually look at the map definition that I exported from Tile, you can see the layers are all inside of this big table, and each one of these blue tables is a layer. How do we know what a tile layer is and what an object layer is? Well, it's pretty easy, right? Because we can see there's an attribute called type. In the case of tiles, it's tile layer. And don't forget that the actual tile data itself is in this data table. If we go down here, we can find an object table, an object layer, sorry. And we can see that the type is actually object group. So here's the collisions layer right here. So first thing I'm going to do is loop through this. So I'm going to loop through all the layers. And I'm going to check to see if the current layer is a tile layer. And if it is, we can just simply do this dot tile layers count equals this dot tile layers count plus 1. And then we can do this dot tiles, this dot tile layers count equals v dot data, which is the actual table of tiles. All good. Now we just need to change the rendering logic as well. So here in the map render function, you can see that I've manually been drawing the tiles. We're not going to have any of that anymore. We're going to use a for loop. I'll do for I equals 1, and then I is going to be less than self dot tile layer count, layers count. And I'm just gonna take all of this and then put it in there like that. Now instead of manually specifying the layer, I'm just gonna write I. So we don't need any of this anymore. Okay, I think that's good. This is good because we can have any number of layers and it's gonna draw each one. But we also need to deal with our object layers. So I'm gonna do else if v.type equals object group. Well, we have two types of object layers, right? We have the collisions one and the entities one. So in the case of the collisions, we can do v.name equals collisions. And we can use this function right here. But we can't have I and V because we're already using that. So I'm just going to change these to J and O. That's going to be V. And then this is going to be O, 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 and O. Now let's do the same thing for the entities. We got a bit of a problem here because the entities are being processed with this big gross if statement right here, which is inside of this for loop. I want to separate this out into its own function just so it's a lot cleaner. So I'm going to take all of this right here, cut that out. I'm going to put in a function, create objects, and it's going to take in the current layer. The only things I need to change is I need to change this to the layer. And then I need to change all of these thises to selfs. Okay, good. So now all we need to do is call that function. Okay. I think that should be good enough. I'm going to save that. To actually see how that looks, I need to add all the resources like the textures and quads. So it's being stored in this texture called Slates64.png. As for the tile set name, if we look in the definition, there's two tile sets, but we're only using the first one, which is Slates 64. Finally, we'll add the map definition to our map dictionary. To actually test it, I've gone ahead and I've set it as the default map. So let's see how that looks. Okay, really nice. Something's wrong with the collisions. Well, I realize actually that my player collider is a little too big. Especially when I try to go through narrow spaces, there's quite a bit of friction there, and there's some areas he can't fit through. I think it's a pretty good practice to make the collider just slightly smaller than a tile, so I'm just going to do that very quickly. Here in the player constructor, I'm just going to change all of these to 30. Okay, that's much better. Another thing I added was the ability to go back to the other maps. So there's a connection between this old map and the seaside. Good. The only thing we're missing now is tile animations. Back here in the tile editor, I have all my static tiles that are not moving, but then I also have the ones that I want to animate. So if I right-click this one right here, we get this tile right here, which has an ID of 744. I want you to remember that because it's going to be important for when we actually render our animations. That what it's going to do is it's going to check to see, oh, this is 744. Do we have any animations that start with that number? And if we do, then it's going to play the animation and render it. So we need to keep that in mind. Now I'm going to actually create the animations here in Tiled first. So what I'll do is edit the Tileset by clicking this icon right here. And that opens up the Tileset editor. Now we have the frames of our animation. We got these four. So this one is the ID of 800. This one is 744, as I explained earlier. When creating the animations, it's actually important which one you have selected. So this should actually correspond to whatever we have here. So I want that to be the start of my animation, so it's important that I click on that, and then I'm going to press the animation editor. And this is a cool feature I didn't even realize existed until recently. You could actually click export as, and you could actually export all the Tileset metadata as Lua, just like with the Tilemaps. So you can get all the animations exported as well, which is really nice, because before I was just creating a table manually and specifying, each number for the frames. Because remember, the animation is just going to be a table of tile IDs. So it's going to be a table that contains 744, 745, 746, 747. So we could actually edit it right here. So I'm going to click the edit animation button, and now I have to find that again. I'm going to select all of these, and you can select multiple frames and then drag them over like that. And you can change the duration of each frame, which is in milliseconds. So each one of these is 100 milliseconds. I can make this one a longer duration, but I'll keep them all at 100, the default, and I'll click apply. So now we have this icon indicating that there's an animation. If we go back to our tile map, we can actually see the animation. All good. Let's do that for our other animations. Well, this flag is also going to be an animation. And this is also going to be an animation. But this is a bit of a trickier case because it's actually two animations that we're going to be creating. The top of the windmill and then the bottom. So I'll select this one first and then click Edit Animation. And then I'm going to Control Select all of the top parts and drag them over. I'll do the same for the bottom parts. I'm going to save that and then export it. Now we can see all of our animations working correctly in the editor. Now we just need to code some animations. Back in the code, I'm looking at the Tileset file that I just exported. The data we want is right here in this tiles table. And what we want specifically is each of these blue tables. So each one of these is the animation data we want. It starts with the tile ID, which, as you remember, is that waterfall. And then each one of these frames is its own table. So it's got a tile ID and a duration in milliseconds. But to actually run that, to update it, I'm going to create a new table object. So I'll create a new file. Call it animation.lua. This is going to be extremely simple. So I'm just going to make one function. So it's going to be one function called new animation, which takes in the frames, which is that blue table we just saw. And all this is going to do is return a new table. So what does that need? Well, it needs the frames. It needs to keep track of the current frame. And it needs to keep track of the time, so it'll have its own timer. Also, we need an update function. So update is going to be a function which takes in self, which is going to be the whole table, and then it's going to take in delta time. Finally, we need a way to actually get the current frame. So I'm going to do a function called getCurrentFrame. And all that's going to do is just return self.frames, self.currentFrame. And we need the tile ID, not the duration, because if you remember, each one of these frames is a table that has a tile ID and then a duration. So it'll be dot tile ID. But there's a bit of a quirk here. We need to add 1 to that, because for whatever reason, you remember that our tile data actually has +1 added to it. It has 1 added to it. But these ones don't for some reason. When you export it as a tile set, it just remains like at the 0-based array, not the Lua 1-based arrays. So we have to add 1 to everything. And I think that's it for the getCurrentFrame. Now the update function is going to be a little more complicated. What we need to do is update the timer. I'll update it by delta time. And then we need to check to see if that timer has hit the duration amount. Yeah. You have to remember, though, that duration is in milliseconds, so we actually need to convert that to seconds for this to work. And if you remember, a millisecond is 1/1000th of a second, so all we need to do is just divide that by 1,000. And when that happens, we reset the timer. And then finally, we add the frame, so we say self.currentFrame equals self.currentFrame plus 1. But that's not all. We need to wrap it around to the beginning. Like, let's say we have 4 frames and it's currently on frame 4. If we add 1, it's going to be frame 5, which is too many, so we have to go back to 1. So if self.currentFrame is greater than the number of frames, and self.currentFrame is going to equal 1. And that should be it for our whole animation object. Just with this one table that we're returning, we should be able to do everything we want with tile animations. Just like with everything else, I'm going to require animation in main. And in resources.lua, I'm going to create a new dictionary called Tilesets. Now you may be asking yourself at this point, geez, we have textures, we got quads, we got the tileset metadata. Couldn't we just combine all of these things into one big super object, and then the maps can draw from that and use all the information? Well, yes, you absolutely could, and you probably should. But I'm keeping things simple in this case, so I'm gonna keep all of these things separate. Now here in maps.lua, I'm going to create a new table called tile animations. That's where we're going to store all these animations and then use that information to draw them and update them. But what I think I'm going to do is I'm going to say if G tilesets has the ID of the current tile set, then what we're going to do is create our tile animations. And that is going to take in this. And what is it going to take in? Well, it's going to take in that tile data. As if you remember from this table right here, all of the animations are contained in this big table called tiles. So that's what we're going to pass in. We don't have this function now, so I'm going to create it. So what we're going to do is loop through that. First of all, we want to know if the tile actually has an animation. So we'll say if v dot, what was it called, animation. Yeah, if it has this table called animation, then what we're going to do is, well, we're going to get this ID right here and use that to store things. So self.tile animations, which is the table we created as a member of the map. It's going to be v.id, but remember we have to add 1 to that. And that's going to be a new animation, and the frames are going to be v.animation. Yeah, it's going to be v.animation. One thing to keep in mind is that when we just pass in a whole table like that and store it in another table, that table is going to have a reference to this table. So anything we change in that is going to change here too, and it's going to change for the whole game. And the same goes for our tile data, I guess, that everything is being stored as a reference. So you have to be careful about that. I might address that later. And that's it for creating our animations. The rest is going to be pretty downhill from here. In the map update function, after I've updated all of my entities, I'm going to update the tile animations. Note that I'm using pairs this time instead of iPairs, because tile animations is a dictionary, not a simple array. And we just call update, that's it. Now, to render all that, we get the tile ID right here from getTile. We're going to see if the tile animations match any of those IDs, if it matches this ID. So what we're going to do is we're going to say if self.tileAnimations has that ID, then we're going to reset that ID to whatever the current frame is. And that's it. That should be all we need to actually see our animation. So I'm going to save that and run it. Oops, simple spelling mistake. That's one thing I don't like about Lua. I'll just fix that quickly and run it again. Wow, there you have it. We got all of our animations running inside our game. I don't know about you, but I think this makes our game look a hell of a lot better. And it really wasn't that hard to do either. Let's see if we can go to the other map and back. Yep, here's the one with no animations, the boring old map. If I go back, it loads just fine. We don't get any errors. Okay, great. We're pretty much done with this whole tile map series. We got most of the building blocks we need to make a whole game now. But there's a few things I do have to fix, or some things have been bugging me since the beginning. One thing I've realized is this is the first video I made in a while that actually has anything to do with tiles. That most of this series has been about making entities or game objects or game architecture. It's kind of straight off course, and I haven't really talked about, you know, the cool things about tile maps, like the way you index into them very quickly, that you can index into a tile map in constant time. And there's so many things about them. And I also want to talk about the camera system, because I know the way I'm doing it right now is very archaic, and a lot of you are probably using the Lua or the Love2D transform stack. So I want to show you how you would integrate that into our system. And there's other things I've discovered over time, like when you screen scale with push or when you screen scale with the canvas, sometimes there's some tearing between the tiles. These are all things I really want to get into, but if you've been through this whole series, thanks for watching. I really appreciate all the new subscribers. I'm looking forward to putting the finishing touches on this. Thanks, and have a nice day.